Let's start the second article, which is rotational kinematics and dynamics. So here you are aware with these two words, what is kinematics and dynamics, but here we have to consider in the addition to these two words, there is a rotational. So we will study these two branches. In rotational motion. But in the rotational motion, which kind of motion you have to consider? Here we have seen in the previous article a kind of rigid body. So suppose I am giving you one example of a rigid body. So can you consider that as rotational motion? So let me give you that. So here I have considered a kind of rigid body and I have taken the cross sections x1 and x2 in which the particles are obeying the circular motion. But if you want to consider such kind of motion as a rotational motion, then the condition is if all the particles of a rigid body perform circular motion and the centers of these circles see in the figure you can see these O1 and O2 are the centers of the circles are steady on a definite straight line. See, in both the kinds, the centers are steady by a straight line. Here the straight line we have considered as y-axis. And the straight line is called the axis of rotation. It is a geometrical line. This axis of rotation, what was the straight line, we can consider as and this kind of motion of a rigid body is called the rotational motion. So if you see from the figure that a rigid body is shown and all the particles, but here we have considered only two particles P and Q for which they are rotating in the circular motion or they are performing the circular motion according to the centers of, see the centers are O1 and O2 which are steady on a straight line. So this is the condition that their centers should be in a steady position on a straight line, which is a geometrical line also. So here we have performed a circular motion on a rigid body for the particles P and Q. When they are performing the circular motion, then this particle P is performing a circular motion with radius r1 and this particle Q is performing the circular motion with radius r2, or we can say the distance from the center, which is the radius. Now the center of the circular motion here for point Q is O2 and here the point is O1, where these points O1 and O2 are on a straight line. Which is y-axis, and with this O1 and O2 are also steady. So this kind of motion I can consider as a rotational motion. Now with the help of this rotational motion, let's start to study the branches of rotational motion. So there are two branches what we have to consider. So the first one is the rotational kinematics. So the definition of this branch or the introduction of this branch can be given by the study of rotational motion without the causes of it is in the branch of physics evaluated, and this branch is called rotational kinematics. Similarly, there exists another branch, that is rotational dynamics. So, the branch of physics in which the study of rotational motion is carried out, with the reasons for motion or we can say for occurring the motion is called the rotational dynamics. So actually this branch is very helpful because in which the reasons of motions are also studied. Now, if you combine these two branches, means rotational kinematics plus rotational dynamics, then you will get a new branch of physics, that is rotational mechanics. Now we will move to the analysis of rotational motion.